Good morning, students. Today we are going to start with Maths 2, chapter number 5, third part of quadrilaterals, in which we are going to discuss the midpoint theorem, converse of it, and problems related to it. That is practice set 5.5. So let's begin. Now here, the very first one is midpoint theorem. Okay, the statement of the theorem is the line segment joining the midpoint of any two sides of a triangle is parallel to the third side and is half of it. Okay, so what is given to us, that triangle ABC is given to us, in which P and Q are the midpoints of side AB and BC. What we have to prove is, we have to prove that segment PQ is parallel to segment BC and PQ is equal to half of BC. Here we have to construct, take a point R on ray PQ such that Q lies between P and R, and segment PQ is equal to segment QR, join C and R. So here we start with the proof. What was the construction? We have to take a point R over here, draw line, means extend line PQ and extend the line from C such that it meets at point R. And what is given to us, such that PQ is equal to QR. This was the means this was supposed in the construction. Now we have to consider two triangles over here. The two triangles are triangle APQ and triangle CQR. In this, AQ is equal to QC. This is already given to us as Q is the midpoint. So AQ will be equal to QC. Then angle AQP is equal to angle CQR, which is this angle forming over here, vertically opposite angle. Okay. And by construction, we have considered that this PQ is equal to QR. So the two triangles are equal by SAS test of congruency. Then I can say that AP is equal to CR. This AP is equal to CR, right? After that, angle APAQ, that is angle PAQ, is equal to angle PAQ is equal to angle RCQ. Okay, this is corresponding angle of congruent triangle. Okay, now as it is corresponding angle of congruent triangle, so but it is forming in the Z, so I can say that AP is parallel to RC. Alternate angle test, AP parallel to RC, alternate angle test, Z is forming over there. Okay, that is in place of AP I can write PB. Why? Because AP is equal to PB. So PB is equal to CR, is parallel to CR. That I can write. Okay. So, and AP is equal to PB. This is already given. So PB is equal to CR. Now, this side is parallel also and equal also. So the given quadrilateral PBCR is a parallelogram. As it is a parallelogram, PR is equal to, this PR is equal to BC. Okay, now we move, is equal to BC, and so PR is parallel to BC also. Fine, and PQ is parallel to BC. Now PQ is half of PR. This PQ is half of PR. Okay, PQ half of PR. So PR is equal to BC, right? So in place of this PR is equal to BC. So in place of PR, I can write BC over here, a construction. So what I can write over here is BC. So PQ is equal to half of BC. From here we come to the conclusion that PQ is parallel to BC and PQ is half of BC. I hope it is clear. Let us move on to the next, that is converse of midpoint theorem. Now in converse of midpoint theorem, the statement given to us is if a line drawn through the midpoint of one side of the triangle and parallel to the other side, then it bisects the other side. Now line L is given, line L passing through the point D and parallel to side BC intersects side AC in point E. What we have to prove is AE is equal to EC. Construction through point C, draw CF parallel to AB to intersect line L at F such that E lies between D and F. This is what is the construction. Now we'll go with the proof over here. uh, Line CF. This line CF is parallel to AB. Okay. So AC is the transversal. This AC is the transversal. So I can say that DAE is equal to ECF, right? As ECF is so in quadrilateral, DBCF, DBCF, DF, DF is parallel to BC, DB is parallel to CF. Okay, so this DBCF is a parallelogram, right? DB is equal to AD. So in place of DB, I can write AD is equal to CF. Okay, as AD is equal to CF. Now we will move on to the two triangles, that is triangle ADE and triangle ECF. Now which things were equal? AD is equal to CF is equal, right? Then DE is equal to EF. Then one of the angle we have proved that it is equal, that is angle ADE is equal to angle ECF. So the two triangles are congruent to each other by which test? By SSA test or ASS test. Okay. So as they are congruent, I can say that AE is equal to EC. Yeah. So here we end up with a proof. AE is equal to EC. From here we come to the conclusion that line L bisects side BC. Okay. So now we start with the practice set 5.5. The very first problem of this exercise is in the figure, point XYZ are the midpoints of side AB, BC, and AC of triangle ABC respectively. AB is given to me as 5, AC is given to us as 9, BC is given to us as 11. We are supposed to find the length of XY, YZ, and XZ. Here what we are going to use, we are going to use the midpoint theorem. Okay, very first thing in the solution that you have to write is whatever is the given part. So given part is AB length is given as 5, AC is equal to 9, and BC is equal to 11. So in triangle ABC, X and Y are the midpoints of side AB and BC respectively. XY is equal to XY is equal to xy is equal to half of AC. This xy equal to half of xy is equal to half of AC, right? So AC is 9, so half of 9 is equal to 4.5. Now the next one, that is xz. Xz will be half of BC. So half of BC, that is equal to uh, a half of 11, that is equal to 5.5 centimeter. Then YZ is equal to half of AB. Midpoint theorem, half of 5, that is equal to 2.5. Okay, this XY is half of AC. Then XZ is half of BC and YZ is half of AB. So first problem is clear. Let us move on to the second problem. In the figure, quadrilateral PQRS and LMNR are rectangle where M is the midpoint of PR. Prove that SL is equal to LR and LN is half of SQ. Now, for very first, you have to consider the rectangle LMNR is a rectangle where LM is congruent to RN, opposite sides of rectangle. Now, as they are sides of opposite sides of rectangle, they will be parallel to each other. LM is parallel to RN, so LM can be parallel to RQ. Okay, as N lies between R and Q, so RQ is parallel to SP. So this LM is parallel to SP, right? Now we have to consider triangle RSP, okay, in which M is the midpoint. As M is the midpoint of PR, LM is parallel to SP. So L is the midpoint of SR by converse of midpoint theorem. Okay, so SL is equal to LR. This SL is equal to LR. Diagonals of rectangle are congruent. So SQ is equal to PR, right? SQ is equal to PR. So LN will be equal to MR. Now MR is half of PR. Okay. So LN will be half of PR. So LN is half of SQ. So this is what is the proof of the second problem. I hope it is clear. You have to go with the converse of midpoint theorem, right? First, you have to move on with the rectangle inside. Then you have to connect it with the rectangle outside. You have to use the property of congruent diagonals. Okay. You have to use the property of midpoint theorem. Okay. And converse of midpoint. Okay. In figure, triangle ABC is an equilateral triangle. FDE. FDE are midpoints of side AB, side BC, and side AC. Okay. Show that triangle FDE is an equilateral triangle. Okay. Now, in triangle ABC, E and F. E and F are midpoints of AB and AC. So what will be FE? FE will be half of BC. Midpoint theorem. This is equation number 1. In triangle ABC, D and E are the midpoints of BC and AC. So DE will be equal to half of AB. In triangle ABC, D and F are midpoints of BC and AB. Okay, so DF is half of AC. Midpoint theorem, this is equation number 3. Now, triangle ABC is an equilateral triangle. So, AB is equal to BC is equal to AC, right? Now, what AB is equal to BC is equal to AC, correct? Sides of equilateral triangle. Now, what I'll be doing? Multiplying each term by half. This each term is multiplied by half by 1 by 2. So, what I'll get? I'll get half of BC is equal to half of AB is equal to half of AC. Now, what is half of BC? Half of BC is FE. Half of AB is DE. Half of AC is DF, right? So FE is equal to DE is equal to DF. From which equation? From equation 1, 2 and 3. So triangle DEF is an equilateral triangle by definition. When three sides are equal, the triangle is called as an equilateral triangle. I hope it is clear. Now we move on to the last problem of the exercise. In the figure, PQ In the figure, PD is the median, okay, of triangle PQR. Point T is the midpoint of PD, and produced further, it intersects QT. Produced QT intersects PR at point M. Okay, show that PM upon PR is equal to 1 upon 3. Right? Now here, very first thing that you have to do is you have to draw QM, and you have to draw DN parallel to each other, such that M lies between P and N. This M lies between P and N. Okay, and N lies between M and R. Okay, now in triangle PDN, in triangle PDN, okay, TM is parallel to DN by construction. So by converse of midpoint theorem, this M is the midpoint of PN, right? So PM is equal to MN in triangle QRM. QRM, right? D is the midpoint of segment QR, right? So DN is parallel to QM by construction by converse of midpoint theorem. Okay. From here we come to the conclusion that Mn is equal to Nr. So here PM is equal to Mn is equal to Nr. So what will be PR? PR is equal to PM plus Mn plus Nr. Right? So PR can be written as 3 times PM. So PM upon PR is equal to 1 upon 3. So here we end up with the chapter quadrilaterals. I hope you all have understood. Thank you. Have a good day.